So on to our program for tonight. I'd like to introduce Jack Davis from JDM. Jack has 18 years of experience in energy, development, and the marketing fields. He currently manages JDM's West Coast clients and was hired by NIA to administer and deliver the Kilowatt Crackdown program amongst a various number of different cities around the U.S. Some other notable programs that Jack has served as advisor on, played a key role, are as follows: Carbon Foursquare, Green Building Opportunity Index, the Deep Retrofit Playbook, and the High Performance Portfolio Framework. So if you're curious about any of those, stick around for the reception and feel free to pick Jack's brain on any one of those projects. I did before this. It was really interesting. In terms of education, Jack has his Bachelor of Science in Civil Engineering from Texas A&M, then switched gears and got his MBA in Marketing from the University of Minnesota. So Jack will be kind of split into three different sections of tonight's presentation, but generally he'll be talking about the Kilowatt Crackdown program at a high level, and Katie will be talking about kind of a boots on the ground look on the front lines, taking a look at different buildings and some common operational savings opportunities. So in terms of Katie's bio, she is a research scientist at the University of Idaho Integrated Design Lab. So we've had her at the office now for about a year. She joined with us back in January, and since then has gotten involved in a wide range of different activities, including fieldwork, doing measurement and verification on projects, conducting operational and investment-grade audits, and doing a fair amount of energy simulation in the lab as well on research projects. So Katie has 3 years of professional experience in the mechanical engineering design world, and also has her bachelor's and master's of science from, that's right, the University of Idaho Integrated Design Lab. So with that, let's go ahead and welcome our speakers, and we'll start off with Jack.
Thank you, everybody. Can y'all hear me in the back okay? Great. Well, we want this to be interactive and engaging, so feel free to stop us if you want to just dwell on a point or dig into a certain issue more. Don't hesitate to ask questions and shout out. We have some kind of scheduled breaks for questions, but we definitely want to get this to be a little bit more interactive from you guys. So as was described, I'm here to talk about the Kilowatt Crackdown and the program we're running here in Boise currently, among some other cities. We have a pretty diverse agenda for you today. We're going to get into a lot of different topics. We're going to get into this program, the Kilowatt Crackdown. We're going to dig into a little bit about commercial real estate and why this audience is always tough to tackle with energy efficiency. Katie's going to spend some time digging into the more technical side of some of the operational opportunities we're identifying through this program. We're also going to get into why competitions work and perhaps even a little behavioral sciences type of stuff. So real diverse agenda, and bear with us, and hopefully it'll be informative for all of us. Just by way of curiosity, how many people, I'd love to get a little sense of your background. Raise your hand if you're from a design or architecture kind of background. What about students? Any real estate folks in here? Building owners? What about green building consultants? Okay, great, thanks. So the Kilowatt Crackdown is essentially, if you want to boil it down, it's an energy efficiency competition for commercial office buildings. And it's presented here in Boise by Idaho Power in a partnership with the BOMA Boise, which is BOMA stands for the Building Owners and Managers Association. So it's a trade association for commercial office buildings. And then NIA, the Northwest Energy Efficiency Alliance. NIA is a regional organization that is funded in part by contributions from Idaho Power. It is utility funded, and the design or intent of NIA is to aggregate the effectiveness of the market solutions for energy efficiency across the Northwest. So it's active in Idaho, Washington, Montana, and Oregon, and does a lot of programs, everything from flat screen TV efficiency to commercial office buildings to industrial and irrigation systems. So NIA has a lot of different things going on, but as was described, I am hired by NIA to run the Kilowatt Crackdown in partnership with BOMA and Idaho Power. Supporting the initiative is these three firms. My firm, JDM Associates, we're a energy management and sustainability consulting firm. Most of our work is in commercial buildings. Obviously, the Integrated Design Lab is a technical resource that is a big part of the program here in town. And then the Green Steps, which is another local consulting firm that I'll describe their role in a little more detail. So it's a lot of different folks involved in the program. So essentially, what is the Kilowatt Crackdown? It is, like I said, a competition. It is a way to challenge the market to take on energy efficiency in a framed, kind of concise point in time, and enable these buildings to kind of compete against each other in a natural environment with assistance provided to them. We are tackling commercial office buildings, 15,000 square feet and larger. That's the population of competitors that we have. And then because Idaho Power is a partner, we want them to be in Idaho Power's service territory so they can take advantage of Idaho Power's rebates and incentives and that kind of thing. The idea of these energy efficiency competitions actually started in Portland, which was also funded by NEA. Back in 2006, we were involved in the first, we basically helped set up the first one of these. And from there, we took it up to Seattle and had a competition in 2008. There we had over 130 buildings participating, which was very successful. That got the attention of some other folks around the country. Louisville, Kentucky did their own Kilowatt Crackdown. And then the idea started kind of popping up here and there across the country. Both, you know, some chose to tackle water and energy. Some tackled sustainability from a whole perspective. But lots of different organizations did these competitive programs in a way to engage their marketplaces. We're happy to have been a part of the ones in the Northwest, as well as some of the ones on the East Coast for Duke Energy. The competitions are, like we think, a really great way to tackle and influence large chunks of the marketplace. I'm going to get there, but about for a teaser, we have about 42 currently active buildings in Boise. 47 signed up, but 42 are currently. Well, yeah, building stock is much different here in Portland versus Boise, but yeah, we're actually quite pleased with the over 40 because of the quality of the buildings that are participating. So how the competition works, we basically started recruiting buildings in the fall of last year. We asked them to sign up and commit to engage for the course of the competition. We helped them with benchmarking their energy use through the Energy Star Portfolio Manager tool. Once that has occurred, we then offered up technical energy audits and site visits. We call them scoping studies, but that enabled the buildings to really get a free resource to identify ways to save energy. And this is where a lot of these operational ideas come from that Katie's going to talk about. Once they have their report in hand, that gives them a sense of what they can do in terms of saving energy, and we encourage them to set a target, energy savings goal, and then build a plans and budgets to enable and make that target happen. And then with the assistance of the account representatives from the utility, Idaho Power, and what I'll describe later, the energy coach, the buildings work to budget their projects or actually implement those projects real time because some of the operational things can happen right away. Once the engineer says, hey, you should try this, a lot of these operational techniques are immediate. But some of them are capital projects that require budget approvals, and that's where the budgeting cycle happens, and we see some of those projects carry over into the next year. In the spring, we'll announce the winners of the competition and also basically encourage those buildings to continue on this pathway, continue implementing these action plans that we've helped develop for them. The competition and the goal that we're trying to really achieve with these buildings is built around what we call strategic energy management. For lack of a better term, strategic energy management is really just making energy a strategic part of your business day-to-day decision making. We have best practices that we're trying to encourage in the real estate community through this program. We want them to set a target and have the ownership or the management of that building approve that target. We want them to document and build a plan to achieve those activities because if you don't have a plan to achieve that target, then you're just kind of flailing your arms around. We want them to allocate some resources. If they're budgeting people and time and resources, then that means they're actually working on that. And then, track and report out the goals and the progress in the energy savings. Just getting people, and we'll get into this a little bit later, but just getting people to react to and think about energy usage in a new way, that in and of itself changes behavior. So that's the kind of framework that the competition is designed around. We're trying to build these best practices in the real estate community so they take off and continue on after the competition winds down. This is just a screenshot of the website for the Kilowatt Crackdown. You can see at the time this image was taken, we had 46 buildings registered in the Boise community. This is still active. You can go online and look at the website and read the rules and all the different language about the competition. We have kind of 3 prize categories that the competition is set up. We have the highest performing buildings. This is, think about it as most energy efficient buildings. These are, you know, as verified through the Energy Star rating system. So how many people are familiar with Energy Star and how that works? Anybody, would it help if I explain that quickly? Just for those who don't know, Energy Star takes your energy use, you describe the space use in your building, how many square foot, how many people are in the building, and it normalizes all those factors and gives you a 1 to 100 ranking of the quote-unquote energy efficiency of the building. So we're using that tool to evaluate the performance of the building. And it's actually becoming a bit of an industry standard in the real estate community. And Energy Star for office buildings really is one of the kind of bench or the platform that most folks are using these days for tracking their energy use. We also have most improved performance. So for those buildings who saw some operational opportunities immediately and they acted on those, we are doing an energy performance year-over-year comparison. And that most improvement is another set of prizes that we'll be awarding. And then we have the grand prize, which is more of a subjective prize, but it's also kind of a way for us to recognize the firm, building, or institution that really went above and beyond and delivered the most value for the competition. So as I mentioned, we'll be awarding these again in the spring of next year. Participants that sign up for the competition, they get, like I mentioned before, free engineering services, essentially. We send an engineer for any building that wants one, with a couple exceptions, out to the property. They do a walkthrough. They write a report. They submit that report to the buildings, and the buildings have a nice, handy set of ideas to act on. These scoping study reports are very operational focused. So we're not only looking for the capital projects like the big chillers and HVAC units that we can replace, which are, you know, obviously cost prohibitive in some cases, but it's those smaller things like temperature set points and damaged dampers and envelope repair issues that can be done quickly and immediately and have an impact on the energy savings. Participants also get assistance in creating this energy action plan. We call it the project bank. And you can see that it has a lot of information that's meant to be a living document for the building. A lot of information here on their energy performance. Here's their energy reduction goals that they set. We think we can save 5% in 5 years or whatever the goal may be. Contact information on the property, an overview, and then this is a project tracking section, which is, you know, when are you going to implement this? Has the budget been approved? So we really want this to be kind of a checklist for them to manage. And I'll get into this a little bit more, but if you think about the average real estate property manager, these folks are very busy, they're always putting out fires, and you need to kind of help them organize their thinking around energy efficiency, and a project bank allows them to do that. Buildings that are eligible will also get free certification for Energy Star. So this means they get a nice plaque or a window decal for their building that notes that they're one of the top 25% in terms of energy performance in the country. So on a 1 to 100 scale, if they're over 75, they are eligible for this plaque, and an engineer has to visit that and verify that property. And Brad here is one of the ones doing that. I'd like to take indoor environmental quality. Yeah. So the reason Energy Star are built into this process, the site visit by the engineer, is because the easiest ways to save energy are to shut out your lights and don't give your fresh air to your occupants. So we don't want that to happen. So the engineer is verifying that the indoor air quality is meeting requirements, and they're not like shutting down the lights or doing something weird. So there is a verification process built into that. So I don't know, Katie, we've gotten 3 or 4 of these underway. Do you know? So buildings are in the pipeline getting these plaques, and you'll hopefully start seeing these here in Boise over the next few months. We also gave each participant or each building their own what we called energy coach. This is the Green Steps team. Many of you know Ken Baker, Sharon Peterson, Susie Hall. They provided kind of a mentoring role for each building to coordinate through the competition, help them with data access issues, help them understand what next steps were in the competition, and identify ways, workarounds, and just basically kind of guide them through the process. We recognize that a year-long competition is a lot for some folks, and so the coach is kind of that, half motivating factor, half disciplinarian in terms of getting these buildings to move along. So what I'd like to do now is spend a little bit of time talking about commercial real estate and this target audience that we're impacting through the program, because it's a unique audience. How many folks work with commercial real estate clients, customers, some of the architects, I'm sure? What's that? Own some. You own some? Good. So you're a real estate magnet right here in the front row. Real estate. Sam Zell? Yeah. I don't know him personally, but. Oh, good. Oh, you're one of Zell's angels? Excellent. Okay. So anyway, the man in the middle is Sam Zell, who founded, among other things, the Equity Office Portfolio, which is one of the largest, at the time was the largest REIT in the United States, which is basically owned real estate all over the country, hundreds and hundreds of buildings. But when you think about commercial real estate, it could be it's a very diverse, wide array of people. It could be investors, a teacher who puts their retirement money, and that retirement money gets put into real estate. That's a real estate owner indirectly. It could be, the big tycoons like Sam Zell or Donald Trump, who are really smart, really aggressive, and really impactful in their day-to-day work. It could be a small local developer or a family who earned money in one industry and decided to put that money into real estate. The industry can be all over the place. Some comments, and they have various motivations and mindsets. They're all basically seeking financial returns out of the building. That's what's really unique about real estate. And by way of background, when I say real estate, I'm thinking about lots of different property types. It could be office buildings, industrial office parks, multifamily apartment buildings. It could be retail strip centers. Real estate covers all of that. But they're all looking for financial returns. Some of them are looking to buy, build, develop, and sell a building and make a profit on the sale. Some are looking for cash flow. They're just looking for rent income that basically is their own income. Some have long-term investment horizons. Some have short-term horizons. Ego plays a role in this industry. I think you see a lot of folks with sharp elbows and big egos that need to be fulfilled sometimes in the way they operate. Right. Transaction focused. This is a industry characterized by transactions like the buying and selling of buildings, leases, lots of changing and multiple parties in the mixture. And some folks are very comfortable with the real estate they have. Some are nervous. Some, the mindset of the industry varies quite a lot depending on who you're talking about. There's lots of functions in the real estate industry, and this also complicates the way you attack this industry from an energy efficiency standpoint. You could have, these are all different job titles that you could see in any given day in a real estate company. Property manager, which is more or less the day-to-day person who's running the building and making sure things are going smoothly. An asset manager is really more of a financial ownership representative that basically hires the property manager in most cases. A director of asset management is managing a lot of asset managers. So you see how this starts to roll up. Portfolio and fund managers are managing investment funds of real estate. So I may be administering a fund of 100 office buildings that fund is retirement income for the California Firefighters Association or something like that. Tenants, obviously, are the businesses that are leasing space in those buildings. Brokers, we all know what those are. They're the ones facilitating these transactions. And then service providers like all of us in this room who are helping with lead consulting or architecture or interior design or HVAC maintenance. all the supporting players who help make these buildings run day to day. And they really play a role in the operations, as we'll see. All right, so within all these roles, there's a lot of push and pull in the industry in terms of stresses and pressures on who's making decisions. And that's where energy efficiency always gets hung up in a lot of these kind of organizational dynamics. Now, for the most part, I'm describing some stuff at large institutional investment real estate firms, but these roles, they may be called something different at a local firm, let's say a family firm here in Boise or a mom and pop building owner. But the functions that they're playing more or less still happen. So you have, in this case, an acquisitions director who is basically somebody who's acquiring buildings into the portfolio. They're buying buildings, they're seeking out and understanding where buildings are. This could be also a new developer who's developing new buildings. They buy something and bring it into the mix, and they hand it over to the asset manager and they say, okay, I bought it, you make it run well, make it financially perform. At the same time, you have the portfolio manager who is financially responsible for the performance of the investment fund, and the acquisition director puts the building into the fund, and the portfolio manager approves it, and they're both looking at the asset manager saying, make it work, make it cut costs, make sure it gets leased up, make sure it's meeting its financial expectations that we kind of put before you. The acquisitions director may say, we think this is going to increase rents by 5% over the next 3 years. That's just a guess. He doesn't know that's going to happen. The asset manager may have to make it happen. So that's why he's under the vice here. He's getting squeezed by these other organizations or other players in the organization within this real estate firm. So the asset manager, as I mentioned earlier, he hires a property manager. So you got the asset manager here. Whoops. He's hiring the property manager, and he's saying, hey, I want you to cut costs. I want you to lease the building up. I want you to make this building perform. And then the property manager also has to deal with this guy, the leasing agent, who's a broker. The broker's trying to get new tenants in the building, market the building, and the broker wants his commission. So he's saying, hey, don't worry about whatever. Just make the deal so I can get my commission and I can go find a new tenant. So the property manager is, again, caught in the middle. So you have all these pushes and pulls within the industry that it can be difficult to figure out where the decision is actually getting made. And that's where we really, where a lot of energy efficiency projects fall into, is where is that decision getting made? And it's not always easy to diagnose who you need to talk to and can you even get to them. So it gets really interesting. This is kind of a schematic cash flow map almost of an actual building we worked on a couple of years ago. So you have basically what you had was some European investors, basically retiree, people putting into what the equivalent of a 401k would be. There's a retirement income is going into a fund, and that fund is here. They go out and hire, and they say, we're going to put a portion of that money into real estate. So they hire an investment advisor who has an asset manager that's going to administer those funds in the real estate world. You also have lenders who are putting debt and equity or debt and mortgages into the mix as well. So they have a stakeholder interest in the situation. And you have an appraiser who's valuing the building. I know how many of you were here last time with Molly McKay when she spoke. So she gave a lot of the background on the valuation and appraisal side of this industry. So this is the appraiser here trying to say, yes, this building's more valuable. The asset manager hires a property manager to run the building on a day-to-day basis. In this case, the property manager did not have in-house engineering. So they hired a third-party engineer. They had another engineer. Now, it just so happens that one of the tenants in this particular building was a high-tech company with some really sophisticated equipment, and they hired their own engineer to take care of the building. So you had two different engineering firms, both going into this building trying to make it perform well. And you can see how difficult it is to get somebody on record here to make a decision and do what's right for the building. The good news is there's a lot of trends in real estate that are helping us in this regard. We're seeing in our work and kind of internationally and nationally expanded investor inquiries into the sustainability of real estate. Those European investors in that previous slide, may now be asking, hey, if you're going to manage my buildings, what are you doing for me? Are you cutting costs through energy efficiency? Are you managing the waste and recycling programs? So we're seeing increased demand for that kind of accountability, if you will. And you also have on the regulatory side, both on the government side as well as just within the financial community, increased demand for reporting and performance. So the Greenprint Foundation is an initiative by the Urban Land Institute, which basically is benchmarking building performance across a number of indicators. It's a voluntary program, but it's very influential. The Global Real Estate Sustainability Benchmark is an international framework for measuring funds. So if you think about, you go to select a mutual fund for your retirement, and you go to you buy Money Magazine or some financial advice column in the newspaper, and they rank the funds. Well, there is this institution called GRESB now ranking funds of real estate on their sustainability performance. And that has, REITs are involved in this too, yep. So if you go online and Google GRESB and read their annual report, they're now saying these funds are doing X, Y, and Z, and these funds are maybe not doing as much. And that's now making people ask questions, well, why aren't you doing that? So it's actually causing quite a ripple effect in the industry. We also see green certifications like LEED and Energy Star continuing to take traction in the marketplace. Nationally, you see a lot of investors trying to really chase what we call trophy assets. So the big New York skyscraper, that has its own little interesting impacts on the market. What's driving that is capital seeking safety. When a fund is investing across the country and they decide they want to sell a building, this is all driven by human behavior. And for whatever reason, New York is where people want to buy and sell real estate. So it's safer to buy a building in New York than it is to buy a building in Salt Lake City from a financial standpoint. And then the last thing, operations continually gets ignored. It is, with all this scattered value chain of organizations and individuals, it's the guy at the bottom in the boiler room who is trying to run the building day to day. When the asset manager is saying you got to cut costs and spend less time at the building, that's where the operations opportunity comes from. So the energy efficiency operational opportunities we're finding are because of this industry structure where it's kind of the least sexy part of the industry. To some, we think it's really sexy. It's really cool. So, knowing all this, how do you engage this marketplace, and why is the Kilowatt Crackdown designed the way it is? We're trying to understand how and where decisions are made. Whether you're selling a client on a project here in town or a new development in Portland or wherever, you need to understand where your client sits in the value chain, and are you able to enable him to sell up the ladder to get things moving. Everybody in this industry has to convince somebody else. There never seems to be an end in person. So you have to kind of create reports and business cases that you can take to your client, and then he can go take to his boss, and his boss can take up the ladder in a way that makes it get that approval finally. And then sell beyond the kilowatt. This is what Molly McKay was talking about, where it's not just about the cents per kilowatt hour you're going to save. It's making that building more competitive and responding to market demands for those green and energy efficient space. It's responding to those tenant and investor demands and making the building more valuable, not just reduce the cost. And I also recognize this is a relationship, excuse me, a relationship-driven industry. Real estate, just right here, we have somebody who knows Sam Zell. That is a networked industry right there. We have everybody in real estate. It's a small world. You go to a real estate conference, and you go to the conference next year, and all of a sudden you're seeing the same people already. So it's a relationship-driven industry. They all know each other, and they respond to each other. And I'll talk a little bit more about this later. That's why the competitive environment really kind of takes hold in this kind of atmosphere. So with that, I'm going to stop and just see if there's any initial questions, and then we're going to get to Katie, and she's going to talk about some of those operational from a more technical side. So you have a mic? What's been the industry's reaction to the competition? Yeah. Well, you saw by that map of the United States that it seems to have a lot of traction. It's a way for the industry to do something themselves in a way they like, and recognizing that they're already in a competitive environment. Yeah, there was one, I think, on Chicago. It was called something else. I forget the name of it, but they've done something in Chicago, I think in partnership with the city. Right, right. Yeah. For this competition? So we had the 15,000 square foot minimum. Yeah, so that was one. In terms of systems and technology, no. We did have a couple of issues with buildings here in town that were on a steam loop, and the energy tracking for that steam system were kind of funky. So those buildings ended up having to drop out because they had to install some sub-meters to even get to the point where they're tracking that energy. So there are some little issues like that we've dealt with, but we're I should say, the competition is all about whole building performance. So whatever that whole building is doing, we're not really, we don't care how within the building you're doing the energy efficiency. We just want to see that whole building perform better. Oh, I'm sorry. It is specifically office building. Yep. So the type of energy that the building uses is not part of the issue. The geothermal versus an all-electric building. We're tracking all of it. It all gets converted to kBTUs, and that's how the Energy Star tool converts it for us. And right. Yeah, and even if we've had buildings, not in this competition, but another competition, where they even had a lobby fireplace, and we were tracking that energy, that gas. It depends on the conversion factors, and it gets into a lot of crazy technical stuff. But in general, because the Energy Star tool normalizes for those different energy loads, we can still do an apples-to-apples comparison. Capital investment light, where you can say, we can take this money very quickly. So I think that's a great segue a little bit into Katie's presentation. I will say, in general, there's some just rules of thumb. It's just like your house. Turning things off when you're not using it. Not having dual heating and cooling happening at the same time in the building, which happens more than you would be surprised. Minimizing use when you do need to turn that equipment on, and then when you do need to turn that equipment on, then make that equipment more efficient. So that's kind of a philosophical way of answering the question. We're actually, at the end of this competition, we're going to scoop up all those recommendations and do a report on what the findings were and what the most common recommendations were. So we'll have some more data on that coming down the pipe.
That's a good segue, I think, to go into Katie's presentations on some of those operational savings opportunities that we've found commonplace through a lot of the audits and buildings that we've been involved with here at the IDL.
Okay, hello everyone. I'm Katie, like he said. Can you all hear me? No? Okay, I'll speak up. Basically, I'm going to look at the operations and opportunities section. As part of the Kilowatt Crackdown, the IDL and specifically Brad and I did a lot of the scoping study audits. So we were identifying the ways to save the energy within the building. These can be broken down into capital measures or operational measures, and we've talked about this already. We really wanted to focus on the operational measures because, as you can see from this picture, this could be quite spendy compared to changing your thermostat settings. So I'm going to talk a little bit about why, and a big reason is the potential savings. So this was a study done by the New Buildings Institute. They did a sensitivity analysis looking at the impact of commissioning, operations, and maintenance variables. And they basically found with bad practices, you could increase energy use by up to 30%, or up to 60%, 30 to 60 was the range. And by using best practices, you could decrease your energy use by 10 to 20%. So those are pretty significant. Kind of going back to that last question, there was a study in Energy Efficiency magazine that listed the top 13 energy efficiency inefficiencies in commercial buildings, and those are listed here. Oops, wrong button. And they estimate that the national total for those is 94.6 billion kilowatt hours per year. That's their central estimate, and that goes up to 171 billion kilowatts per year nationally. So, duct leakage is what they found was the #1 inefficiency. So those are big numbers. That translates to $9.6 billion per year as a central estimate, or up to $17 billion per year nationally. Another reason we like to look at operational, and everyone's favorite reason, is the payback. They're more cost effective generally. This chart shows, this is just the commissioning cost versus the whole building energy savings. So this line here is a payback of 1 month versus 5 years down here. So even these ones way out here, you're getting a 5-year payback. And what they summarized it as, the median savings were 22% with a return on investment of 91%. And of those measures that they believe are out there, only about 5% of those operational measures have been implemented. No, and this was just a study with 300 buildings. They looked at commissioning costs. So basically, this boils down to get the same savings, it will cost 20 times more in general to do capital measures rather than operational. So with the operational, they're generally low cost, no cost, easily installed, generally in-house, immediate payback, and they don't require the same design time, bid preparation, evaluation, and response. So with that, Better Bricks has kind of given us 6 categories for operational measures: envelope integrity, equipment scheduling, sensor error, simultaneous heating and cooling, outside air usage, and design issues. And I have a lot of these measures to show you, so I will try to get through them quickly. But basically, just good to keep in mind, these are common issues we see, and really to focus on these during a retrofit or even a new building design or commissioning process. There's always room for improvement there. So first, with the envelope integrity, we don't like to see gaps. So you can see here, one side of the room got sealed and the other side just didn't get that those flutes sealed out. You can also, I don't know if you can see, but right here is some insulation, and then it just didn't go all the way across. So you've got a gap in that insulation. Pretty easy way for heat or air to escape out. More gaps you can see here using an infrared camera or a smoke pin, or by looking at details. There's always a way to find gaps that could be filled. Here's just window sealing in general. This right here is just a roll of the seal left on the outside, so clearly wasn't finished. And this is just a really big gap in those seals. So you want to see those come down to the corner. They do shrink up as time goes on, but during install, this should be considered unacceptable. So good things to keep an eye out for. I won't say. So water damage is another good indicator that there's air leakage. If water can get in, obviously air can as well. Bugs are good indicators of leakage. So soffit lighting, if you've got bugs hanging off of there, there's usually heat escaping, and so they're accumulating there. Windows, you see tons of windows that will get cobwebs on them, so both good indicators. Something else to keep an eye out for is air pressure. I couldn't find a photo of the usual issue we're looking for, which is when you open the front door of a building. If air is sucking in, that means it's going out at the top somewhere, so that's a good indicator. Here you can see we have the opposite problem. There's a piece of paper actually just stuck to this door because the building is overpressurized. So that says we need to look at our relief air dampers or something. That system isn't working correctly. And then, of course, revolving doors are great because you don't get that when I open the door, all the air rushes in. So we like to see those. Other things to watch out for are within the infrastructure. You know, if a pipe gets removed and there's just a hole left, that's a great way for air and heat to escape. Also, ceilings and plenums, people might drill through for IT reasons and then take those cords out later. And just making sure, even if you are installing some wiring, to seal around that so that air doesn't go where it shouldn't be going. Another issue we see are penetrations that are intentional, but maybe aren't the best design method. This is a fan in the penthouse of a tall building. It's to cool an elevator equipment room. But what that does is give an opportunity for air to come all the way up the elevator shafts and just escape out this fan opening all day. So that's quite a bit of air. Same idea can be seen here. These are exhaust fans. These are actually off, and you can see how much of the snow they're melting around there on the roof. That's just from stagnant. The fans aren't on, but the air is escaping and melting that snow. So with those, these can easily be resolved with, say, a motorized damper that closes when your building shuts down. That way the air is sealed and it can open back up for the fans to operate the next day. We also see decommissioned mechanical shafts or any part of a building, boiler shafts that are up there and just the boiler got removed and nothing got sealed up. So there's no reason to not seal those and keep the heat from escaping. We see elevator vents on almost any big building, so we kind of dug into this issue a little bit more. What we found was that venting of hoistways is not required when there is a fire sprinkler, an approved fire sprinkler system in there. So that's obviously something you'd want to check with your local fire codes, but this is that same issue of stack effect where the air gets to leave from every floor and go right out that opening all day long, all night long. So another thing to look into, if you have a chance to seal those, we should do it. Otherwise, add a motorized damper so that it only needs to open when the emergency is occurring. So more savings, equipment scheduling, lots to do with thermostat settings. So we want to make sure the temperatures are set right. The times are set right for occupied and unoccupied. And then don't forget the weekends. So this one here, they had the setbacks and the temperatures right, but they forgot to set their weekends at all. So the building was coming back to temperature for all day and all night, all weekend, which is a lot of time. Another good practice for thermostats is to give occupants some control, but not all the control. So a couple degrees up and down so they feel happy and comfortable without changing how the building runs completely. We see fake thermostats once in a while, so it's been done. Also, when you have two units serving one space, it's a good practice to give an offset between those temperatures so they're both not cycling on and off when one could stage on first and the second follow as needed. We'd also like to recommend testing high-performance thermostat set points and schedules. This is that same sensitivity study from NBI, and they show with just thermostat settings, you can increase your usage by over 30% or decrease it by over 10% just by, say, instead of doing a 74, 72 all the time, you could move up to add the setbacks at night or really get aggressive and set those temperatures back all the time. Another issue with scheduling, almost all water loops can have reset schedules. This was a case study done at the University of Texas. They had five buildings, and they put, this example here is for a chilled water loop and condenser loop. The baseline usage are the top lines, and you can see how much, almost 4 million BTU hours per, 4 million, or 0.4 million BTU hours evenly across that whole time. But what they found was an average savings of $0.66 per square foot across all 5 of those buildings by just implementing reset schedules on their chilled water loops. More scheduling for cooling equipment. You want to make sure to drain unused cooling tower basins. We've seen basins that were at, I think, 90 degrees in the middle of winter. That was just due to a faulty electric pan heater. So having steam come off that building at all times, that's a lot of heat to just keep that swimming pool up there heated all the time. Also, we saw one building that the bypass damper was located above the roof deck, so it was not in the insulated building envelope. And as a result of that, he was having to drain and refill his towers on a daily basis when it got to those shoulder seasons where it might be freezing at night, but during the day he needed those on. So that's definitely something you want to avoid. Back to the dampers. There's outside air, relief air, exhaust dampers. They should all close during unoccupied times. Any dampers being left open after hours is just giant holes for that air to escape. We can look for little cracks along the windows, envelope integrity issues, but really these giant dampers are going to have a major effect compared to those window cracks. Exhaust fan scheduling turned out to be a big deal because of that same stack effect issue. You can have the general building exhaust off during unoccupied. You generally want it off. That does give you some fan savings, but really the major savings comes from that conditioned air you're exhausting for no reason. And so by not exhausting that conditioned air, you don't have to reheat or recool that air come morning or all night while that exhaust fan's on. We really like to see time clocks. They're inexpensive and they can really make a difference as far as turning off all these exhaust fans at night or turning, you can control all your exterior lighting with a simple time clock. So those are really easy installations. During our night walks, we like to look and just feel how much air is escaping out of those exhaust fans. So again, back to turning off the exhaust fans and then adding the dampers so the opening is sealed during after hours. Here's kind of a look at the stack effect issue. You can see for the winter time, you're pulling in a lot of infiltration down below as the heat within your building rises and escapes out the top. And then we kind of made up a graphic for if you have an exhaust fan running all night, you're really pulling a lot more air out the top and getting a lot more infiltration. So that's just all air you have to recondition that you wouldn't have had to were those exhaust fans turned off and the building sealed up. Sensor errors play a big role. I don't know if you guys can see this, but one thing to look for is just impossible scenarios. So with return air being 73 and outside air being 56, there's no way this mixed air is 51. So somewhere there's a sensor error or something is not working as indicated. That's a good sign to go look to resolve that. We also have here, we think in this one, the supply and return temperatures were just switched. Maybe on the graphic that doesn't matter, but if there's control logic attached to those points, that's obviously going to cause issues. We don't want to see equipment cycling. That usually indicates the building is not performing as it should be. Some things to check with economizers specifically are wire connections, the set point that economizer is scheduled to come on or off, and then just being available to check those economizers during times when you should be in economizer mode is always a good way to find those issues. Here we saw over here, this was a brand new CO2 demand control ventilation install that they were thrilled to have in their big conference room so that they didn't have to keep the outside air up as high as they needed. And basically the wires just never got installed, so that hadn't been running since they had purchased it and thought it was installed. So always good to check if things are disconnected for one, or if they don't seem to be functioning as you would expect. Over here we have a central computer that just got completely unplugged because someone was unhappy. It kept overriding their thermostat set point. They decided not to use the central computer, and I'll come back to that later actually because we think that may have caused other issues. Simultaneous heating and cooling. With energy recovery ventilators, they're great. You get to recover that energy as it leaves the building, but you don't want them on all the time. There is economizer times that you want that wheel to stop, and you get the 100% outside air at the temperature it's at. So those do require some scheduling and shouldn't be on all the time. For simultaneous heating and cooling, this was a case study at Texas A&M. They had 12 air handlers installed in a giant arena, and 2 of the 12 were stuck in heating mode for an entire year. Because there were 12 units, they didn't notice until this $75,000 extra showed up on their bills, and at that point they went in and were able to find out what was causing the issue. This is a tough one because there were no comfort problems, there were no complaints. This would have just been a case of needing to go up there and check either in your EMS or physically if what was happening up there was what you expected. So it's a tough case. Again, the recommendations are to frequently check equipment mode, both in the EMS and physically, and then review the monthly energy use. This really speaks to benchmarking and how that can help you with your building performance. Outside air usage. Outside air dampers should be open during occupied mode. It is, like we talked about earlier, one of the biggest ways people try to save energy. If they're in a pinch, if the heat can't keep up or the cooling can't keep up, a lot of times the operator will go close those very first thing they do. It can solve a lot of problems, but again, that causes issues elsewhere. We need to make sure and keep that indoor air quality up where it should be. Outside air dampers, just placement during design. These are obviously too close. They're going to cycle back under. And these outside air dampers, it's just kind of unfortunate because these are the outdoor heat pumps. They're rejecting heat. It's coming up and going right in the outside air dampers. Back to this building control that we saw was unplugged earlier. When we went on the roof, their ERV wasn't functioning at all, most likely because that control was unplugged. So just verify that your controls are set and that you're getting that outside air. General design issues. One big indicator is thermal comfort. You can see here we see lots of fans and heaters. That means people are not happy with what the building is doing. Uh-oh. Oh, there we go. We see a lot of outdoor condensing units indoors. That's not ideal. Both of these scenarios. This one here, the air handler had to run 24 hours to keep air going across those units. This one here, I won't play that because it's a video and I'm in a rush, but it's basically a big fan is freewheeling because air is escaping through this room because there are outdoor air units in there that they had to keep air flowing across. Other issues, stratification fans are great fixes for, big atriums or somewhere where they're not getting the desired heat. Again, the cooling tower bypass, it should be down within the insulated envelope of the building so it can be used properly. There's lots of coordination issues. This was the outside air damper that was forced to be closed because when it was open, these pipes would freeze during the winter. We don't like to see throttling. It can increase pump energy, but it also generally indicates that things were oversized. Throttling that valve is going to prevent it from seating correctly later, so we want to avoid throttling at all costs. Bottlenecks in your airflow. If you have one size duct over here and then a tiny duct here, that's not how the design should be carried out. So those are my operational opportunities, and we can take questions quickly maybe.
Go with a couple of questions, and remember, so for our online audience, we have to speak into this mic, which is only broadcasting to them. It's not amplifying, so go ahead and raise your hand and also speak up when you're asking the question. And if I can't catch you, Katie, if you could repeat the question, that'd be great. But we've got time for a couple questions before we get back to Jack. Does anybody have any questions for Katie? Anything? Ernie?
Well, I was just wondering if through this whole analysis process you're doing, if there's any, any interface with the actual guy that runs these buildings, the building manager, because half the time it's like the janitor and he doesn't even know how any of this stuff even works, He just goes and turns it on or turns it off and mops the floors, There's a little bit of a breakdown in that whole technology scenario, isn't there?
Yeah, through the Kilowatt Crackdown program, that's our escort around the building is the operator. So we go with him or her, and they show us around the building, and we talk through these things on site. They're not generally surprised when they get their report, and oftentimes those operators have done a good number of the operational measures before they even get the report, just from us walking through with them and explaining as we go.
Or are they surprised at some of this stuff, though, or are they knew it all the time and didn't want to say anything? Or
we've had generally good feedback and experience. I've heard of times where you have to be careful and there's touchy situations, but all my experience, at least, they've welcomed the help. We're very understanding that they generally run in reactive mode, so we're not pointing blame at them saying, what were you doing with this? We know if the outside air is closed, they were probably having an issue and they haven't gotten back to it.
But do you find a lack of their understanding of the building systems? Is that kind of universal? Or
that's always a possibility. We've seen both, where there's a wide range of operators and their abilities.
Sure, there is.
Any other questions for Katie? No. All right. Well, we'll have one more Q&A session at the end of Jack's final segment. So just bear with us while we transition the lapel microphone.
That's actually a really great question about the skill levels of the people running these buildings, because we're finding that there's always a need to train people better, to get people to understand their own buildings better, because you get a guy who got used to one building, then he gets moved into another property that has a whole different set of systems and control technologies, and they're kind of just thrown in the water. And so it's always an opportunity to train people and in the industry, it's unfortunately that when people are trying to cut costs, training budgets are one of the ways they cut costs. So we'd love to see more of that, and NIA and Idaho Power have a lot of great programs to do that. So we're going to switch gears again and talk a little bit about the competitive nature and why this competition framework is working. Competition is an emotional thing. It triggers an emotional response. And a lot of the energy efficiency world tries to think things through in a very engineering, very analytical, very rational way in terms of, well, if it's the payback is this, then you must do it. But we're all people, and people act in an emotional way. So we're trying to, through a competition, tap into some greater motivations beyond just the dollars and cents to move the market forward. Competitions work when you're layering in your program on an existing social network. I mentioned earlier that the real estate industry is a very relationship-driven industry. So you're kind of more emotionally engaged when you're competing against somebody you see every day or you know or somebody you used to work for. So real estate's really good. It's a small, comprehensive community. They're naturally competitive. You may be working for one firm 1 year, and that firm gets sold or bought or the building changes management, and you work for your competitor the next year. So there's always these relationship dynamics. They're self-referencing. By that I mean they look to each other for best practices. They don't want to get left behind, and they don't want to not keep up with their competition. And so they're always checking with each other to understand what's the state of the industry and what they should be doing to maintain that competitive advantage. And so when you layer a competition onto a self-referencing community, you're able to insert some of those best practices in a nice way. And the competitions allow you to apply some new strategies that are sometimes not possible through other mechanisms, and I'll talk about those in more detail. So I'm going to throw some behavioral science terms at you, just because I think this stuff is kind of fun. Does anybody know what cognitive dissonance means? Basically, what cognitive dissonance is all about is the way our beliefs and our actions interrelate. And when what we're doing goes counter to what we believe, that creates dissonance in our head. So one of the things we do in the competition is we put information in front of the participants, and we show them what their actual energy performance is. And if that doesn't jive with their internal belief system, it actually creates a little bit of uneasiness, and that we tap into that uneasiness to cause action. The feedback mechanism of new information put into people's heads is a way to get drive action. Prizes and recognition. Again, we're all emotional. We like to be recognized and like to get kudos for our achievements. This is a picture from some of the winners of one of the Seattle competitions, and that is the world-famous Kilowatt Cup, which is a trophy that the winning building won. Now, what's interesting about that trophy is we knew in Seattle we were going to do multiple years of competition. So that trophy is like a Stanley Cup. It has the building name, but then they lose it if they don't win the next year, and it goes to their competitor. So it rotates around town based on who's winning the competition. So this is all about getting that emotional competitive dynamics flowing and helping them move forward and tapping into everybody's need to want or desire to be recognized for what they're doing. Peer pressure. We're trying to also generate a little peer pressure among this community. This is a screenshot from the Kilowatt Crackdown website. We call it the status board. And the intent of this is to show your building and what your peers are doing and kind of stimulate that idea that you don't want to fall behind. So, for instance, if you're, this second building here and you have a lot of gaps here and all your competitors are getting the little ribbons, that creates a little, peer pressure to do more and to meet the social norms of the community you're in. Self-efficacy is really this idea of do you feel like you can actually tackle a problem? Do you have the are you empowered to tackle that problem? One of the realities of the property managers and building engineers in this building is they're just swamped for time. They don't have the training. They don't have the time. They're in reactive mode, as Katie said. So we put these coaches at their disposal. These coaches enabled those people to do more than they could normally. So the coaches is a strategy we're using to help those market players move a little farther. Reciprocity rule. This is just kind of like the golden rule. Do unto others as you would like to be done with unto you. If you do a favor for somebody, there's an obligation there. And the coaches are constantly doing favors. And then when the coach comes around and turns and picks up the phone and calls that building and says, hey, I need you to update your data, that reciprocity kicks in and that obligation. So it's really just a fancy way of saying personal relationships drive this. Again, these people are busy. One of the biggest hang-ups in energy efficiency is I just don't have time or I don't know where to go. So we try to, throughout the year, break things down into easy steps for the competitors. We say, don't worry about the rest of the year. Just benchmark. That's all you want to do first. Okay, once you did that, let's investigate and do a scoping study. Okay, once you do that, let's go implement the projects. We're just taking them, we're leaving a trail of breadcrumbs for everybody to follow. We're making it simple. And we're giving them small encouragement and small wins across the year to continue to build that enthusiasm. Otherwise, they just get lost in the maze and they'll just give up. It happens time and time again with this type of audience. And it's not, their fault. It's just because the industry and where they sit in the industry, they're busy, they're compelled to do, they're reacting to so many different things. If you think about a property manager, envision the mayor of a small town. That's really what the property manager is. They're dealing with fire and life safety issues. They're dealing with budgets and accounting, noisy, complaining tenants, safety issues, insurance, taxes. It's a really, and then energy is in there somewhere. So it's a lot to ask these guys. This is my favorite kind of behavioral idea, loss aversion. Has anybody heard this term before? Loss aversion simply means that we are compelled to act more on the thought of losing something than the thought of winning something. So there have been experiments that shown that your behavior at gambling changes. You're more reactive to the thought of losing $100 than the thought of winning $100. If I'm going to lose $100, that's something I have now. I'm going to lose it. I'm very cautious about that. But if I'm going to win $100, I'm going to win something I don't have, so I'm a little more cavalier about that. So loss aversion is a powerful technique to get people to do things or react in certain ways. So the way we use this in the competition is, you remember that buildings get certified with the Energy Star plaque. So they get that plaque on the wall or get that notification as something they can use in their marketing. They can show their tenants. They can enhance their competitive stature. They can show the local regulators. It's a physical, very visible way to kind of show them and demonstrate what they have, what they've achieved. So we are, through the lab and Brad's work, we're certifying lots of buildings in town. What we're actually doing, though, is we're now building a bunch of plaques on the walls that people can now lose because these are only good for 1 year. And now we want those people to have something they can lose in terms of energy efficiency. If they don't maintain that building performance levels, they could lose that certification. So this loss aversion kicks in and creates a constituency of building owners and managers who now feel like energy efficiency is part of their DNA. And that's kind of the whole rationale for why we spend the money to do that. So if, you were to go do a competition in some kind of program, some of the things that we found that work is, these work best in situations where relationships already exist among a community. Whether it's an industrial community, competitions have been real effective in university dorms. There's a natural relationship there, et cetera. You could do it in geographically defined areas where you have a small core downtown that people, a business district that people relate to each other. Campus and buildings. We worked on a building in Seattle that had 2 different law firms that were competitors in the same building, and we were able to help generate a little competitiveness between the 2 law firms in terms of energy efficiency and sustainability. I haven't done this one yet, but I've always wanted to do a city versus city rivalry. Dig into where the local football rivalry is for the high school football teams and do a energy efficiency competition, city versus city. That would be a lot of fun. But these competitions work where you have these already existing social dynamics in place. The last thing I just want to wrap up on some of the results we're seeing and what we're kind of finding from previous competitions as well as already here in Boise. This is a lot of numbers. In the competitions we've done in Seattle and Portland, we had, collectively over a couple of years and multiple iterations, over 250 buildings, was about over 50 million square feet. Over the course of those competitions, NIA was able to document over 6.6 average megawatts of energy savings through the competition. And that is within the first year of the competition itself. So it's not what happened after the competition. It's actually just within the year. So that added up to $3 million in energy cost savings just within those buildings in that first year, and mainly due to a lot of operational changes. Lots of elevator stack effect type of issues that got repaired. Boise, we have 47 buildings that signed up. That represents 3 million square feet. Obviously, the building stock here in Boise is a little smaller, but it's again a great. We were very happy with that. Roughly 17% of the office market is participating in this program here in town. What we're seeing right now already is a great buzz in town about the work that's being done. Buildings are proud to be a part of this. We're finding buildings that are currently active. 43 have kind of currently approaching the finish line, if you will. If you add up all those 43 buildings, that totals about $3.7 million in annual energy spend that those buildings are actually spending every year. 28 of those buildings have gone all the way to create the project banks and created those action plans. And so those project banks are, going to last long beyond the competition. And Idaho Power and their team will be working with those buildings to work down that list and continue to push those projects through. You can see that we have over 350 projects identified just for those 28 buildings. So lots of ideas to save energy that are in the hands of this real estate community through this program. They're all setting their individual targets for the buildings. The average is about 6%. And over the next few months, we'll be wrapping up, collecting the last data set, evaluating those savings, announcing the winners, and kind of determining the overall impact of the program in the first quarter of 2014. This is an interesting chart we pulled together from the Seattle and BOMA competitions. And basically we took the scoping studies, the engineering walkthroughs occurred over many months in the competition. So we zeroed it all together and said, this is on the right or the left-hand side of Energy Star score. So the higher the score, the more energy efficient that building is getting. So we said month 0. This is the month that the engineer visited the building. And so you have 6 months of energy beforehand, and then what happens afterwards. And you can see that the building engineer walks, he gives them those ideas. As Katie mentioned, some of those ideas get acted on right away. Some of those go through a little bit of thinking and budgeting, but then you start seeing the average Energy Star score going up over time. So you can see the effect of having that real intuitive, real educational walkthrough. And this is the average. This is the average of about 75 buildings. So this is, I would say it's anecdotal. This is not statistically, verified, but it's a really good indicator of the value of seeding those ideas in these competitions. What we also have found is actions that we identified in those project banks carried through beyond the competition. This is a small survey that we did of participants in in the Portland and Seattle competition, and almost everybody budgeted projects for the following year. Just about every, the small sample size is 32 respondents, but it's, again, kind of interesting. They all said they're going to continue to track energy use. Again, that gets back to that best practice we're trying to encourage in the marketplace of strategic energy management. 63% said they felt that the competition and their participation increased the number of projects they did, and those they were already thinking about doing, they did it faster. And again, almost everybody said they'd participate again. And we've seen that in other markets where we've done multiple years of competition. So what do we do next? Coming up in the next few months, we're wrapping up data collection for all these buildings in Boise that are participating. We'll be doing some participant surveys and figure out what they're doing and their intent is down the road. We're actually counting up that list of 354 projects that we've identified. We're actually trying to track every single one of those, or as many of those as we can, to see what kinds of projects they're actually budgeting. So that's really good market intelligence for us as well. Is there a reason they don't like to go do the heat pump replacement project? So is there a reason they don't want to go do this one, or is there counterintuitively a reason that they do like this other type of project? We're going to do a little preview. There's going to be some information about the competition at the BOMA Symposium in February. I don't know if has anybody been to that event here in the room? It's pretty much the premier real estate industry event in Boise. It's about 600 real estate professionals from the state of Idaho. So there'll be some information about that in February. We'll be evaluating with some third-party evaluators the energy savings across the competition, and of course announcing the winners in probably more like March, April, May timeframe. But that's what we're heading down and wrapping this thing up. And it's kind of, when you look at recruitment all the way to the wrap up, it's over a 2-year journey for us, and one that we've really enjoyed taking. So that's kind of my last little bit, and I don't know, Katie, you want to come up too if you want to have any questions or discussion about some of the stuff we presented for you. I know we're all over the map, and it's kind of a buffet of ideas to throw at you guys, but any questions or things you want to talk about?
Yes, I think we've got time for about 5 minutes worth of questions. Remember to raise your hand, and I'll get you with the traveling mic.
Has anybody considered a motivational way to make our buildings more efficient through like a capitalist method? And I would sort of compare it to like the ambulance chasing attorney who says, if you win, then you pay me out of your winnings. So in your case, it might be that you go there and you develop this little industry where people are consultants, and if they save energy, there's some contractual agreement, they get paid a percentage of their savings. So you get this whole industry of people going and really marketing this idea and get result that way.
Yeah, so there people have tried that and are doing it. There's this whole world out there called performance contracting, where a big efficiency consultant or equipment manufacturer will actually provide financing, install the project, and actually own that project for a while. So it's like no cost to the owner of the building. And they peel off some of the savings for themselves. So it's kind of that model of capturing the savings and using that as the incentive to do the project. What typically tends to happen is they have to be really big projects to make it all pencil out, because the transaction cost and the legal documentation to get all that worked out is tough, as well as the validation of the energy savings in and of itself adds more cost to the whole idea. So I think lots of people are trying to figure that out. You see more of that in the government, municipal, university kind of institutional buildings, because those institutions have a little bit more of a longer time horizon and are willing to enter into that kind of contract. In commercial real estate, you see very little of this, because a lot of building owners don't want to attach another obligation to their books from an accounting perspective or a legal perspective in case they want to sell the building, because the buyer may go, well, what is this? That looks weird. I don't want that. So it's out there. I don't think anybody's solved it yet.
Katie, when you were talking about some of the design issues some of these buildings had, like 2 air handling units were way too close to each other, that seems like a pretty big problem that's high cost effects, like you'd have to move one. Have you seen any low cost solutions to any of those things?
In that one in particular, it might be, maybe you could make a duct out into an area that actually had fresh air, or duct them separately. But yeah, there are a lot where the mistake was made in the design phase, and really going back to fix it isn't even an option for most of the buildings. So it's kind of unfortunate that it happened at that building, but maybe through methods as this, we could prevent it from happening in the future.
Seems like that chiller bypass or the cooling tower bypass one being on the roof would be a hard one to retroactively fix.
Yeah, they drain it every year. They could put a bypass down below. You never know.
There's another question.
You mentioned at some point that there was some feedback about the 1-year period for the competition being kind of long. And I was thinking the whole time that it was kind of short because it really misses being able to include an entire capital cycle. Because by the time you got there to do your benchmarking, they're probably already putting their capital plan together for the following year. So I'm curious how you decided on a year and if you've given consideration to timing it such that they could get in a full capital cycle.
Sure. So we're very interested in what happens in that year and the energy savings that are achieved in that year. But this is very much a long-term play. So we're actually trying to catalyze within that year practices that carry on beyond. So yeah, it's nice to give some buildings awards for what they did within that year. But we recognize, and especially in real estate, their budget cycle is kind of the fall. They're always budgeting for their building in the August, September, October timeframe. And we kept it to a calendar year just because it's just mentally easier for people to think about. Okay, 2011 versus 2012. We actually did a competition a long time ago where it was like a mid-year to mid-year kind of thing to try to work around some of those budget cycles. And people just having trouble thinking through, okay, we're going from August of 2012 to August to September of the next, it was just too hard to communicate. I mentioned earlier in one of the Seattle competitions, we knew that we were going to do multiple years, and so we built the competition around that. So we actually did a basically back-to-back 2-year competition, back-to-back year competition, so it's a 2-year frame, because we wanted to pick up those projects in that second year. And so we have tried that as well.
Quick follow-up question to that for Mr. Gorton's question. Do you see many of these projects embark on higher capital campaigns afterwards? Like maybe 30% of them are then interested in doing that cycle, even though it's not maybe captured in the competition, that at least it still happens, right?
Right. So the statistic there that, I forget the percentage, but 80% of them we're budgeting items for the following year. Those, when you hear the term budgeting items, that typically means it's a capital project. Not always, but it could be. There is some cost to some of these operational things too, but we haven't quantified it to know the dollar level because we don't actually, through the competition, have that level of granularity on those. But we do typically see some activity, and a lot of this is really just you're putting things in people's face a little bit that they didn't have time to think about. It's kind of self-evident once you kind of look at the report and say, oh, okay, we should do that, and they can sell it pretty easily up the ladder. But because people are so busy, they don't have time to even get to that first stage. And so the capital projects come, we have noticed that uptick, but we haven't analyzed it to a fine detail yet.
I had a question regarding, Katie, you mentioned like these buildings that have design issues that unfortunately can't be, they're cost prohibitive to be corrected, and as well as that graph that, what was it, 30% of the loss was duct leakage. I mean, it seems like a lot of these items are falling on us design engineers. I was wondering if maybe a spin-off of all this was, if anyone's given any thought to putting together a document, for design for dummies, I guess, to point out all these mistakes us design engineers are doing, or it might be, we think we might be doing the right thing, like that ventilating or relieving the elevator shaft, and maybe a lot of the stuff we're doing is not necessary, or we're never known to oversize stuff like that pump. So.
I guess as far as I know right now, I'm not aware of design manuals or anything coming out of this competition.
Yeah, this competition is really focused on existing buildings. So we're not, having specific resources in there for designers. But I would say industry-wide, the voice of the operator is not always in the room when the design decisions are made. And I think that's a bigger issue for these kinds of things. If you have somebody who knows how to operate buildings, and integrated design practices are trying to get this in there. But if you have somebody who knows how to run buildings after they've been built, and they might catch some of these things a little faster if they're in the room when those design decisions are made. But systemically, it's kind of hard to make that happen. So that's a big issue.
I believe we have time for one more question.
Just be a follow-up on Rick's question is that if any of you know the IDL and how we operate, this would make sense to you. If you don't, get to know the IDL better. But we do lots of lunch and learn series to design professionals in town and all over the southern Idaho largely. And so a lot of this information will just naturally get fed into our lunch and learn presentations that we give. So that will be a real organic way that a lot of this information will get out to the designers in our community.
Great. Since that was just a follow-up question, we have time for one last new question. Here you go, Doug.
This is kind of an operations question follow-up about operations, people being in the room. When the State Department of Energy Resources did the K through 12 schools upgrade a few years ago, one of the things that we found was that often when a big new school was built with 30 rooftop units, the maintenance staff knew from day one they didn't have people just to replace filters that needed to be replaced. And I wondered if you found that, and if there's an organized proposal that you have for combating it. Maybe it's just getting those operation people involved early on.
Yeah, so many of you know Amory Lovins, the Rocky Mountain Institute founder. He wrote about that problem 30 years ago. He called it the chasm between the developer and the operator. And I've met lots of folks in real estate who look at a new development plan and go, okay, why are you installing these lights? Because I'm going to rip them out. It's cost effective for me to rip them out the day you open the building because they're just, the wrong things. It gets into capital decisions, how the money gets allocated in the design phase versus the operations phase. It gets to the fact that the operator is not in the room because they're not even hired yet until the building's way through 80% of the design, if that. It's a structural issue in the industry, and I don't have any quick solutions right now other than raising awareness, like we're doing here today, and bringing that to your client's attention, asking hard questions in those when you're in the room with somebody.
And I'll go and take a crack at answering that as well from the IDL standpoint. So, our internship programs generally have been intaking engineering or architecture students, training them at the lab, having them work for us for 2 years while they go to school, and then having them go back out into the industry. We've been trying to explore different types of internship structures. I think we call it the RCM, Resource Conservation Manager, where we'll have an intern that can actually be on loan with the building operator. So they'd still be doing an internship at the lab, but they would get them maybe 2 days out of the week. And then he would help the building operator, he or she, manage the building, do some of their projects they don't have time to do as a way for them to get trained up and also to provide a little bit more bandwidth for some of these operators that are just completely swamped with their projects. That's kind of something we've been toying with and trying to explore, but we haven't actually made it happen yet. But that would be one step as well.
One more thought. There is another approach for some of these. For some organizations, this is a policy thing. For a school district that builds probably, many schools a year probably, they probably have some performance specifications that are documented that apply to all their new development decisions. In those documentation, they could add some language that would add this kind of in there. Same with, a hospital chain that has, or anybody who's building a lot of buildings over time and has some kind of new development specifications or policies. That's another place you can kind of insert this idea.
Thank you, Jack and Kate.